Syllabus Mathematics Book 2, Exercise 1B, question number 12. Kiran wishes to cut some squares from a vanguard sheet with a length of 64 cm and a breadth of 48 cm. She likes the squares to be as big as possible and she does not want any leftover vanguard sheet. What is the length of each square and how many squares can she cut altogether? To understand the question, let's examine the vanguard sheet. The length and breadth of the sheet are 64 cm by 48 cm respectively. Since Kiran wants to cut some square sheets from this vanguard sheet and she does not want any leftover sheet, it means that the area of the square sheet she wants to cut is the same for all the sheets. In other words, she wants to divide the vanguard sheet into equal parts of square sheets. This concept refers to the highest common factor HCF because the area of all square sheets would be the same, while the HCF is the product of common factors. Here common factors are the square sheets whose area is the same. Also, we can find the length of the side of a square sheet with the help of HCF. Therefore, I'll factorize 64 resulting in 2 times 2 times 2 times 2 times 2. Factorizing 48 gives us 2 times 2 times 2 times 2 times 3. HCF is the product of common factors, which is 16. Since all the squares are of the same length, which is 16 cm, while length of the side of a square is common for each square sheet. Therefore, 16 is the highest common factor HCF of 64 and 48, as well as the length of the side of each square that Kiran wants to cut from the vanguard sheet. For the second part, to find the total number of square sheets that Kiran wants to cut, I will divide the total area of the rectangular shaped vanguard sheet by the total area of the square sheet. The total area of the vanguard sheet is the product of its length and breadth, which is 64 cm multiplied by 48 cm, equal to 3072 square centimeter. The total area of the square can be calculated by taking the product of its two sides, that is 16 cm multiplied by 16 cm, which is equal to 256 square centimeter. Now dividing 3072 by 256 results in 12. Therefore, Kiran will get 12 square sheets with any leftovers. Question number 13. A class has between 30 to 40 students. Each boy in the class brings 15 chocolate bars for a class party to celebrate Teacher's Day. The chocolate bars are shared equally among the 20 girls of the class and their form teacher with no leftovers. Now, first part from this question is, how many students are there in the class? And the second part of the question is, how many chocolate bars does their teacher receive? In this question, we are given the total number of students, which is between 30 and 40. But we need to find the exact number of total students. The number of girls is 20, but the number of boys is missing. Each boy in the class brings 15 chocolate bars and shares them equally among the 20 girls and their teacher. This means the total number of chocolate bars is equally shared between 21 people. We don't know the number of boys in the class. We also don't know the total number of chocolate bars brought by the boys. If we could find the number of boys, we would be able to determine the number of chocolate bars easily. So let's say the number of boys is x. Then the total number of chocolate bars would be 15x. And the number of girls, including their teacher, is 20 plus 1 is equal to 21. I'll write the inequality equation according to the statement as follows. Boys plus girls is less than or equal to 40. I'll subtract 20 from both sides to eliminate the positive 20 from the left side of the inequality. We get x is less than or equal to 20. Since x is less than or equal to 20, there are infinite values of x including negative values. However, in the question, the number of students is given as positive 30 to positive 40. So I will only consider positive values of x, which range from 0 to positive 20. I have checked the values of x equals 1, 2, and 10, but these values of x do not satisfy the given condition. For example, for x is equal to 1, it means that the number of boys is 1. Then the total number of boys and girls becomes 20 girls plus 1 boy is equal to 21 students. However, the equation states that the number of students in the class is between 30 and 40. For x is equal to 2, the total number of students becomes 22, which does not satisfy the condition of 30 to 40 students. For x is equal to 10, although the condition is satisfied, and the total number of students becomes 31, which lies between 30 and 40. However, the problem arises again. If each student brings 15 chocolate bars, the total number of chocolate bars becomes 150. But we can't share 150 chocolates equally among the 20 girls and their teacher. If you try to share 150 chocolate bars equally among the 21 people, then each person will get 7.14 bars of chocolate. So don't attempt this. This goes against the premise of the question. If you choose 14 as the value of x, this number satisfies the condition of the question. If there are 14 boys in the class and each boy brings 15 chocolates, the total number of chocolates becomes 210. If you share 210 chocolates bars among 20 girls and their teacher equally, then each girl, including their teacher, will get 10 chocolate bars. And this is the solution to the second part of the question. Therefore, the true value of x is 14, which is actually the number of boys in the class. Initially, we calculated different values for x, such as x is equal to 1, x is equal to 2, and x is equal to 10. But these values did not satisfy the condition of the question. However, when x is equal to 14, it satisfied the question. Therefore, the number of boys is 14. The number of girls in the class is 20. And the total number of students in the class is 34, which satisfies the condition of the question. Now, if each boy brings 15 chocolate bars, the total number of chocolate bars becomes 210. And each girl, including their teacher, will get 10 chocolate bars. One last thing, the calculation done in red is just for your clarification. So consider it as your rough work. All the neat work is done in black.